Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of number sets. This is Standard 7.2a in the great state of Texas, and we are using item number 3 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got a Venn diagram here, and what we have is we have a rectangle within a rectangle. So set K represents rational numbers, and we'll need to make sure we understand what a rational number is. And then within that rational number set, we've got set L, which represents integers. All right, so that's going to be integers. Let's make that blue. We'll kind of bring that right down here, integers. All right, so one thing that we need to know that every integer is a rational number simply because that set L is completely included within set K. All right, so what are our definitions? Because we're going to need to find an error in the diagram. All right, so these are numbers that can be shown as ratios. All right, so a ratio, think of ratio, rational number. So a ratio can be, think of it like a fraction, okay? So think of it like a fraction. So any of these numbers you see like 3, negative 3/5 is a fraction, 7/4 is a fraction, negative 7/12 is a fraction. Even these numbers in set L, since integers are part of a rational number, you can make 10, right, a fraction if you make it 10 over 1, or 3 over 1, or negative 8 over 1. So you can always make an integer into a fraction, okay? But typically what we'll do is we'll put in the integers box. Integers are whole numbers that are either positive or negative. If it can be only represented as a ratio or a fraction, then we'll stick it outside of that set L, put it into the set K. Integers, on the other hand, are going to be whole numbers. And so we're not looking at no fraction, no decimal, and it's going to either be positive or negative. So 1, 2, 3, 4, 5, 6, 7, negative 8, 10, 27. As long as there's no decimals, no fractions, we're good to go. So all of these, take a look. 10, 3, negative 8. They all fit. They're all whole numbers, no fractions, no decimals. They're the positive, negative. All right, so our issue is going to need to be set K. So here's the question. Can anything in set K be slid into set L? Can you turn negative 3/5 into an integer? No, that's as simplified as that fraction can get. There's no way to make that into a whole number, positive or negative. What about 7/4? Well, 7/4 is really 1 and 3/4. So it's still a mixed number. Doesn't really help us, and we can't turn that into an integer. But look at this one right here. Negative 12 halves. Okay, so if we divide up, right, you can always turn your fraction into a decimal by dividing up. 2 goes into 12 6 times evenly. So it's going to end up being negative 6, which means, yes, it is a rational number, but its correct space is actually going to be down here within the integers because it also fits within that tighter or smaller category of integers. So even though it looks like a rational number and it looks like a fraction, you always need to be thinking, can I simplify it into an integer? Because if you can, it belongs down there. So let's take a look at our answers. We need to remove negative 8. No, it's fine. Remove 3. No. Move negative 3/5. No, we do not. Here we go. Down at the very bottom. We need to move negative 12 halves to set L because it is an integer. And what we had to figure out is that really it's negative 6. So yes, D is our answer. And there we have it.